This is such a game changer for web performance. We've been having a sort of AI revolution recently, and web performance hasn't been getting that same love, and that's because it's incredibly nuanced and a lot of performance is actually subjective. When you apply a performance fix to your website, you need to really profile to find out if you improved things or not. And if you did improve things, did you make other things worse? I'm on Debug Bear and I've got this website speed report for HBO.com. And if I open up the website in my browser, and mind you, I'm on a very fast internet connection, you see we've got this main featured image here, and it turns out that this image is indeed the largest contentful paint image, and that's highlighted in the LCP element section here. There's the image, and there's the image URL. You see it's requested at around the half-second mark. It's got a low request priority, okay? And the thing that I love about these website speed reports in Debug Bear is the video recording, because it's very easy to scrub through and find out what was the exact visual state change. There's a lot of interesting performance metrics here, and by the way, I'm zoomed into the page, that's why things are looking a bit truncated. But the largest contentful paint, well, it's not terrible, but it's not ideal. But what is the supposed game changer for performance that I was talking about? If we scroll to the bottom of this section, you see we've got these recommendations, and there's a bunch of them that we'll show, but I want to focus on one in particular, and that's around optimizations to do with the LCP element, the largest contentful paint element. As you can see here, the LCP element was requested at a low priority, and we've got a recommendation here to suggest that it should be loaded with a high priority, since that will impact your core web vitals and it could also have an impact on your search engine rankings. And don't forget the most important part, it will affect your end user experience. Where applicable, you can open up a recommendation like this, and we will show you this run experiment button. And it's practically one click, well, 2 clicks to be specific. Click on run experiment, and we'll add this preload into the head of the document. What I really like about this feature is no extra code is needed. You don't need to fiddle around with stuff. And don't worry, this won't be written to your code base, so you don't need to worry about accidentally making things worse. We are all about tools, not rules. That means profiling before arbitrarily adding these preloads. In this case, the one-click experiment feature has added in a preload tag for the image that was on the HBO website that you just saw. And we also add a fetch priority high, because preloading is one thing, but making sure that resource is downloaded with a high priority, that's a separate thing. In this case, we're doing both. Let's scroll a little bit further down, and we've got this run experiment button. I've already run the experiment, and it can take a few minutes to run, so let's just check out the results. Here it is. You can see the lab score has improved a little bit, and for sure that factors in the largest contentful paint improvement. And you can see that we've shaved off about 1 second from that LCP time. You've also got this film strip comparison view. You've got the baseline, and the baseline is effectively the run that we were just looking at previously before the experiment was applied. And then you've got the actual experiment where we pretty much preloaded the LCP element and added a fetch priority of high. Now, don't get me wrong, the film strip is useful, but I sometimes find it a bit much to process. So I scroll straight down to the video recording, and that gives me this nice overview as to what improvements have been made, if at all. That was a little bit quick, so I'm going to scrub through, keep going back, and there you go. There's the image. The video recording on the right does look somewhat improved from the video recording on the left. And it looks like that LCP element comes in around 1.8 seconds, whereas the baseline version, without any experimental code applied, like the preload, comes in at 2.7 seconds in terms of the LCP. I want to rush through some other examples, so I'm not going to spend too much time talking about the request section, but just be aware there is a request waterfall, which is incredibly detailed, and somewhere in here will be the LCP element, and I guess that is down here. You see we've got the LCP badge. It's telling us that there's a new fetch priority high attribute, whereas previously there wasn't. It was actually a low priority resource. And you can see the before and after of how that request downloaded in relation to all the other resources on the page. Let's take a look at another quick example. This is H&M, a popular clothes retailer. And on their main website, you see that they've got this main featured image, which I'm suspecting will be the LCP element. And because it's so prominent on the page, it's so large, it will be interesting to see how they're performing with largest contentful paint. And it looks like it's not too great. That is quite a long waiting period just to see the main image. If, again, we go to the film strip like we did last time, yeah, that's not ideal. And very quickly, if we go to the video recording, Yeah, that doesn't feel good, does it? And you can see the text actually appears where it says back to school, but them being the website developers or designers, they were expecting the text to contrast nicely with the image in the background, but it doesn't because the image is not there. And this should tell us everything we need to know. That image was being requested at the 3-second mark. That's not how long it took to display. That's just when it started being requested. It took about half a second to download. It was a low priority request. None of this is really great. So let's scroll down to the recommendation section. And this time there's another kind of interesting recommendation here. It says, as a recommendation, you should initiate the LCP image request from the HTML document. What does that mean? Well, if we scroll back up, click on the largest contentful paint metric, and we've got the screenshot, which is really helpful, but you've also got the LCP image discovery, which is such a cool feature of Debug Bear, where we will essentially show you how the image came into existence. In this case, this will give you a somewhat truncated request waterfall visualization, so you can focus on just the LCP resource. Here's the LCP resource, but rather than that image just being part of the HTML, it actually was initiated by a JavaScript file, and that JavaScript file was initiated by the HTML. And that's what we call a request chain. Request chains aren't ideal, especially for something as important as an LCP element. And that's why the recommendation is saying, hey, maybe you need to consider initiating that LCP resource from the main HTML document. As usual, we'll open up that recommendation, click on Run Experiment, and check that out. The code is a little bit different now, and I don't mean that the URLs are different. Of course, they will be different. This is an entirely different website with different assets. What I mean is that it's effectively preloading the entire request chain, which in this case is pretty much just a JavaScript file, and then the actual image, which is what we can see right here. One thing I really appreciate about this feature is that it also adds the as script or as image, which you need, otherwise it doesn't work. And I always forget about those attributes. We've got the URL specified, we've got the as script, we've got the fetch priority high. This is all looking good. Let's run the experiment. And just like last time, I've already done this because it can take a few minutes. All right, very nice. We've got a Debug Bear website speed comparison report with the baseline version that doesn't have the preloads applied and the experiment version that does have the preloads applied. And straight away, I can see there's an improvement to the largest contentful paint. All the other metrics for the sake of this video are somewhat out of scope. But again, when you're watching this, you shouldn't treat these preloads as a magic bullet. Sometimes when you take a resource that was previously being downloaded very late in the process, and suddenly you make it one of the earlier resources that gets downloaded, you can have an impact on other things, especially with bandwidth competition and so on. But so far, this is looking nice. There's an improvement to the LCP. There's the film strip comparison view, and it's very clear to me that there's an improvement in when that image gets displayed. But as usual, we will use the video comparison tool because just so much nicer. There we go. Yeah, that improvement was significant. So around 2.5 seconds, that main featured image came in. And if we scrub through, the main image on the baseline version came in at around 4 seconds. Big difference. And let's keep scrolling because videos are nice, but sometimes you just need some accurate metrics to make sure that there is an improvement. Previously, the LCP resource was only being downloaded at the 3.5 second mark, and now it's being downloaded at the roughly half a second mark, less than that. It looks like the time it took to download the LCP resource also increased. Whereas previously it was taking around 300 milliseconds, now it's taking around 700 milliseconds. That could be some sort of natural variance, if you like, between test runs, but it could also be that we're downloading the image a lot earlier and the image is having to compete in terms of bandwidth. Oh, and don't forget the request priority, instead of it being low, is now high from the start. Browsers can sometimes upgrade a request to high, which I think was previously happening, but if you know a resource should be high from the start, let the browser know. And that's with the fetch priority attribute. I want to go through one last example with you. This is Currys, another popular retailer, lots of electronic goods and so on, and they've got this banner on their main website. The banner is an image, and it will be interesting to see if our suspicions are confirmed, whether or not that image is actually the LCP image, and it looks like it is. It's highlighted in the Debug Bear website speed test. There's the URL to that image. Good. It's being requested at 2.7 seconds. And remember, that's not when it gets displayed. That's just the point in the page's timeline, if you like, when it gets requested. Not ideal. The duration not too bad. It's a high priority request, that's good. And like we've been doing from the start, we'll make sure to watch that video just to get a feel for what that loading experience is like and really be able to slow it down. That's, whew, yeah, 3 seconds, that's when the banner comes in, and I see layout shifts there as well. Let's see if we're given that usual recommendation, and we are. The recommendation is to initiate the LCP image request from the HTML document. We can open that up and we get that helpful request waterfall that only shows the resources that are connected to this LCP resource. In this case, it looks like we have the main LCP resource, which is this image right here. And that was requested by a JavaScript file, the LCP initiator. And that JavaScript file was requested by the main HTML document. One thing that's interesting to me is the LCP initiator, the JavaScript file, actually had the defer attribute on it. We just verify that over here, defer is true. So using async or defer on a script tag when that script requests the LCP resource is questionable. I think this is a good candidate to try out this experiment. I'll click the run experiment button. There are the preloads. It's preloading the JavaScript, adding a fetch priority of high, and it's preloading the actual image, the banner that we just saw with a fetch priority of high. That's 2 preloads. I'll click run experiment, but in this case, I have already run the experiment. There's the baseline and there's the experiment. We've got a lab score that has actually decreased, so things appear to have gotten worse, and it looks like the cumulative layout shift is not doing so great. And right off the bat, it doesn't surprise me that if you make a banner load in a lot earlier, that maybe there will be a lot more layout shifts than what was originally expected. In fact, I can click on this cumulative layout shift metric, and there we go. It's highlighting the banner very clearly. And that is why it is extremely important to profile these things. Don't just apply these optimizations thinking, as long as that metric gets better, that metric being the LCP metric, then everything else will be fine too. No, you could actually end up making other elements worse. But that being said, this video is all about this one recommendation to do with the LCP resource. Layout shifts is out of scope, but we do have a lot of interesting resources on it, so go and check that out. I'll link to it in the description. If I click on that largest contentful paint metric, okay, so the banner's appearing as usual, but I need some figures. All right, this stands out quite a bit. The LCP request start time previously, without the preloads, was happening at the 2.5 second mark. Now it's happening at the 1 second mark. Fantastic improvement. And again, I don't know if this is just normal test run variability, but it looks like it's now taking half a second to download that resource, whereas previously it was taking around 300 milliseconds. And if I scroll down, there's the request waterfall. You can see, where is it? Oh, here's the LCP resource. Again, things are looking a bit squashed because I'm very zoomed into this page for the sake of a video recording. I am just curious about this, however. If I click on timings, it looks like we're paying some extra costs when it comes to a connection being established, possibly because this is the first resource that is on a new domain. We can verify that if I go to the columns and enable the domain column. I might have to zoom out at this point. One more zoom out. There we go. So typically it looks like resources are on currys.co.uk. But then if I look at the LCP resource, that is one of the first resources on media.currys.biz. If you end up preloading a resource and you force it to download a lot earlier than what it typically would have been, that resource may be hosted on a different domain or subdomain. And if it is, it might be the case that connections can't be shared or reused. When that's the case, the first resource on this new domain, or you might end up having to pay a heavy cost when it comes to the establishing of that connection. Sometimes it can't be avoided, and you can use little tricks like just how we saw the preload. You might be able to use a pre-connect or something like that. But for now, it's just something to be aware of. Enough of looking at the request waterfall because I really want to check out the film strip. That banner, yep, does look like it's appearing earlier, but as usual, it has to be the video. Ooh, that was a lot quicker. Okay, 2.5 seconds. Just to be clear, 2.5 seconds on the right side, and on the left side is the baseline version without the preloads. If we scrub through, when does that appear? All right, 3.6 seconds. So a big improvement when it comes to the LCP resource. However, as we did see, we've now worsened the layout shift effect. And at that point, you would have to start looking into various techniques you can use to mitigate against layout shifts maybe reserving the space for the banner up front, maybe inlining the markup for that banner directly into the HTML, using something like CSS aspect ratio to make sure that space is reserved, and doing the same for other significant components on the page. That's it for this video. Hope you enjoyed seeing those recommendations. Not only do we have a lot more recommendations that we haven't covered in this video, we also have quite a few others that are compatible with the one-click experiment feature. Be sure to try it out and let us know in the comments if you have any questions. See ya.